There we go. Okay. Now everyone should be able to see my screen. And so we were at this part of endpoints. So very quick reminder here. We had done an initial implementation of actors here, and we wanted to take this from being just local actors to being distributed actors, at least in the very simplest sense. And so we had sketched out some thoughts somewhere. Let's see, it's where we had here on how we were going to approach it. And basically, our idea was that each actor was also, or each actor system, I should say, was going to correspond to, was going to run on one physical system and was basically going to be its own server. And each of our actor IDs was going to have both a location that basically designated which server it was running on. I think right now we have that being a host and a port, and then an ID that would be like a unique integer or long identifier on that particular server. And so that way, when we had one of these actor systems and you had a actor ref, let's see if we can look at what we had here. Let's see. Oh, here we go. When we created one of these actor refs and we don't have the actor locally on our machine, then what we're conceptually going to do is we're going to call the server that does have it on its machine. So that's basically what we were in the process of implementing. And we had really just gotten started with that. We had created a couple of endpoints. And so we're starting to explore using ZIO HTTP and using its endpoint API. And so here we've defined two endpoints. So we've got our send endpoint that we're trying to be kind of RESTful. So this is post actors ID send, and this expects an actor request, which is basically a binary encoded version of the request. And it doesn't give you back anything because it's just fire and forget. And then we have an ask endpoint that's actors ID ask. It also expects a request, and it's going to give you back a response that's a binary encoded response. So we had created those endpoints. And then I think where we left off last time was we were just basically starting on the implementation. So right now I have this thing called actor server. Maybe it'd be more accurate to call this like roots or something. But you can see each of these is basically, well, if I, because VS Code is not working great for me, if I compile this, then we'll get some big error here that basically says this is a route. So so an endpoint is a description of an endpoint without any implementation. And I could use this to generate either a client or a server. And then to actually use this in a server, I need to implement it by a couple ways, but the easiest way is I can just use this implement function. And then I provide it with a handler that's going to take the inputs to that endpoint and is actually going to do something with them. And we left off last time with just defaulting to saying we're just going to blow up and say they're not implemented yet. So I think the first thing I want to do is I want to actually implement these. And so I think we can see to implement these, we're going to need some additional state here. And one easy way to do this is to add a service to this, basically kind of delegate to a service that's going to be responsible for implementing this. And then to actually create the server with these endpoints, we're going to need to provide an implementation of that service. And that service is going to have some state that's probably going to come from our actor system and is basically going to be this map of these actors here. Naveed, I see you asked a question about, yeah, so definitely like discovery is something we haven't implemented here. I think we're probably not going to implement, at least in the kind of first version. I really want to just get this like working first, because I think you're seeing just in the number of sessions we're spending on this, that there's a decent amount of kind of work here. But then maybe this can be the basis of we can do some other sessions where I could see doing more like distributed type things of consensus or things like that. So I think that could be a cool thing to do down the road. But I think right now we'll just focus on implementing this. And I see Nabil is typing as well, so he may have some suggestions for me. He is deep into ZIO HTTP, so he may have some ideas here of how we can do this. So he says I can replace the handler. Hold on a sec. Let me go to my actor server. So I can replace that with handler. So like that, Nabil. Let's see. Without the case, okay. Oh, that's lovely. There we go. Go team effort. All right. So I will do the same thing here. Okay. And so now what I think I'm going to do here is I'm going to create a service that's going to basically wrap up this logic of this actor system. And so I think with my maximum creativity here, I'm gonna call it the actor system service. So this will be zio.actors.internal. And this will be trade actor system service. And it'll have a companion object. And so if we think about the interface for it, I think we basically want it to essentially do exactly what we've got here. So I think as with all these things, we've got these two methods right now. So we've got, say this is going to do send, which is an ID that we could either call it just a long, or I think we have a local ID data type for this. So maybe it will be slightly more strongly typed here. And we'll say this is a local ID, and it'll take in a actor request. And it's going to give back an actor response. And then we can have ask that, oh, and sorry, send is not going to give back the actor response. That's just going to give back in. And I will import ZIO here. And my actors. Okay. And then down here, I'm just going to implement my accessors just to make this slightly nicer for myself. Okay. And then I can just delegate now to these methods. So now here I should just be able to say actor system service.send local ID request, and actor system service.send or .ask, I should say. Okay, and if I check the types on these, you'll see that these now require the actor system service, which makes sense. And so maybe the next thing I'll do here is I will combine these. So I could say val routes is equal to routes send and ask. And so each of these represents an individual route. And then routes is just a collection of routes that we'll try to match one after the other here. And then I can actually turn those into an app by doing routes.to HTTP app. And so now this, I think, has a simpler type. This, I believe, is basically HTTP app of actor system service. And let's see what he says. I like the pattern of endpoint.implement handle function, whatever. I like this over the supposed to typing in the lambda, giving a name like. Yeah, I mean, I think this seems quite lovely, but I'm sure there are other ways you can do it too. But yeah, this seems quite nice. Definitely a good suggestion there. Okay, so now we've got we've obviously kind of punted a little bit of we need to actually provide this actor system service here. But now we have this HTTP app that we can now have a server spin up and go ahead and serve. So let's start to get that going. We've got a little bit of, we got a lot of things to do, so we can pick which one we want to do first, but we can try to do this one first. So basically, I think what we want to say is this logic here is like the initialization of the actor system. And so we want to add something as part of the initialization of the actor system. And I think we basically do server.serve. And then we can call this, let's see, yeah, we already have internal imported. So this can just be actor server.app. And then this server.serve, if we, let's see, I don't think I can click through to ZIO HTTP here. But this is basically going to essentially never terminate. It's just going to, because it's just going to serve this thing. It's going to wait there forever while we go ahead and serve things, which we don't want to do. So I'm going to fork scope this so that this just runs in the background forever. So basically we're saying, hey, part of our startup is we're creating this background process. And let's see, I'm sure I have things server. Yep. I'll have bigger problems too after this, but that's a good one to fix. Server.serve. Yeah, and so I need to import my ZIO.HTTP. Okay, and now, behind a whole bunch of other stuff, I'm getting an error that I need to provide some other stuff. Because you can see that we need this actor system service, which is right. And then we actually need a server here, and we need a scope for this guy. So let's do a little dot provide. And so I'm going to start by just creating a little dummy for myself here of this actor system service. So we'll say live, and I'll make it the simplest thing possible to start with. That's just going to build this actor system service. And then here we can say provide actor system service live. And then I'm going to start with server default just to, I think, get this compiling. Then we'll come back to that in a second here. Okay. And so now this is compiling. So we're saying, okay, as part of our startup here, we're going to create the server. It's going to use this actor system service, which we still need to implement. And right now it's going to use this server.default. Now, the only problem with this is that this is going to use all the default settings as far as like host and port and stuff, versus we actually want to use the ones that we have from this config here. So I believe instead of this, I believe it's server.live we can use. And then this expects a server.config. And so then I can say something like server config is equal to server config dot default. And then I believe it's got some operators. I think it's called host. And I can do config.host. Let's just make sure that actually works before we go on. Oh, and then down here, I can just do zlayer.succeed server config and wire those up. Okay, and we do, I think it's server.config. Let's see. let me go for a second to ZIO HTTP. I think it's with, no, it's port. Let's see. Oh, it's binding host name and port. Okay. Okay, there we go. So now I'm using the host and port from my config for this server. I'm starting the server that otherwise is going to have the default settings, and it's going to use this actor system service to actually implement this thing. So now let's work on implementing this actor system service. So I think the key piece of state that we're going to need here is this thing, is basically this ref that contains all of the actors that are on this server and their IDs, so we can look them up. So let me grab this. And we might want to make like a new type wrapper for this, but I think right now I'm going to leave it as is. So let's make that a dependency. And then maybe I'll have another variant called make that's going to take that as a parameter. So I'll grab this again. And this will just give us back one that doesn't have any other dependencies. I always like this to make the to kind of make the first class one have all the dependencies as layer inputs if you want to wire it that way. And then you can always have another one, though we may actually not even need this. It may be fine to just use this, and we can just put them together. So now that I have this as dependency, then and I not ref.make, but just ref. Okay, now that I've got that as dependency, I need to provide this in here. So I could do zlayer.succeed actors. Okay, so now I got all my information coming in, and now we can actually work on implementing this. And so here, I always like to start with just zlayer and a for comprehension. And so I'll just grab these actors out of the environment. Then I'll make a new implementation of this actor system service. Yeah, so Nabil makes the great point that, yeah, I mean, I think the only reason I can't literally do it as he's done is just I decided to do the local ID instead of the ID. But yeah, maybe we could actually take a page out of his playbook. Let's just try doing this. And yeah, I mean, I think I can probably make those endpoint definitions be super succinct there. So I think this can just be handler of actor system service.send. Is that happy? Let's see. Let's just down for a sec. Let's see. Implement handler. Yeah, that should work. So let's see what we got going on here. That is certainly not a helpful error message. Oh, let me make sure. Okay, I think that's why. Yeah, I think one potential disadvantage of that is like there's a lot of type level machinery here. Let me just make this yield question. Yeah, so I think that's really nice here of like, that's a super succinct way to write the endpoints. I think maybe the watch out would be we saw when we had something slightly off there, we were not necessarily getting the most helpful error message. But yeah, that's kind of really, I mean, that's let's see, why is that not happy? Oh, because this should be, these need to match up. So it is, yeah. So I mean, that's very succinct. That's very nice. And we can see that does enforce the type safety, though sometimes the error messages maybe aren't the best there. So that maybe is the watch out for that. But yeah, I mean, that's super nice. And at that point, you could even maybe inline this in here. But yeah, that's very cool. Yeah, Nabil, that's exactly right. I hadn't updated this from being the local ID to be the long, so those didn't match up. And yeah, I mean, it was right to say it didn't work, but it was not exactly pinpointing the error in the simplest possible way it could. Okay, so let's work on this implementation a little bit more. So we'll yield an actor system service. And we got to implement these two methods. Yeah, that's true. I could do that in the codec there. Maybe we could look at that. Yeah, we could actually play with that. So if we wanted to do that, so I think that means that these all go back to being local IDs. And then my endpoints, these, let's see, I believe I can map these. Not transform, that's right, because I need to do it both ways. Let's see if I got this right. Let's see. Oh, it's correct. That makes sense. So I can just then do. There we go. I think I'm probably even. Yeah. So yeah, that's nice. All right. That's good. We're like making things cleaner with the power of ZIO HTTP. All right. So let's get into this here. So we've got to implement this send method, which now is saying, hey, I want to send this to this local ID, which at this point we know that this is actually one that we're responsible for. It should be in this map where there's some kind of protocol error here. And it's got this binary encoded request. So let's start by unpacking the value from this ref. And then we can do map.get ID, match on that. And so we got these two possibilities that there's actually an actor in there, or there's not. Okay. So the not case is easy. So here we can just blow up with some error message. This should not happen if we're doing things right. This is the case where we got to do some real work here. So we've got an actor, which is great. So we can call the actor.send. But the actor is expecting a typed message, and we've got is this actor request that has a binary encoded version of its request. So we've got to somehow take that binary encoded one and decode it, which right now we don't really have the information to do because we don't have a schema for that. So let's look at that in 1 sec. I'm just going to check. There's a yeah, sorry, one more. In a real, I would put the path parameter for the ID in a val. Yeah, that's a great idea. Yeah, let's, no, this is all good. So yes, so we could say val local ID is equal to, I can just extract that whole thing out, right? That's power of functional programming. Oh, not the send part, but just this part. And then I could take these two. Let's see, and okay, it doesn't like the fact that you relied on the auto application. I like the auto application, but it doesn't. Okay. So yeah, that's a great one from Nabil. So yeah, now this looks like super. I mean, I don't think these could really be any more clear now. So that's very cool. Okay, so back to what we're doing. So we don't really have enough information here because what we need to have is the schema that's going to let us turn the encoded request for this actor back into the actual typed request that we can use to call the actor. So what I think we need to do is we need to add that to really our map here. We need to say that for each actor, we have associated with it a schema that we can use for the requests to that actor. So I'm going to add that as a parameter here. The auto application, yeah, it's definitely not perfect, and yeah, you can fall back on it. So maybe it's for the best. So I'm going to bring in ZIO schema here, and I'm going to change this thing to also having a schema. The more we add here, the more this is probably telling us it wants to be like a more specialized data structure that wraps us up at some point, but I'm going to defer that a little bit. And now we're just going to have to take this and we're going to have to push that change through places here. So I think here, and then yeah, the schemas are going to be really important, and I think we're going to be doing some more refactoring based on the schemas. So I think it'll be a fun opportunity for us to like play with ZIO schema a little bit and think in that like schema-ish way. Okay, so then I'm just going to get back to compilation here, and by adding some question marks, then we'll see what these question marks are actually telling us. Oh, I just need parentheses here. Okay. And then I'll just leave this as a question for now. Okay. And then we were, let's see, there was somewhere here we were just casting this, so we'll be a little bit more type safe here. And here. Okay. Yeah. So Walden says it would be interested in a dedicated symposium on ZIO schema. Yeah, that could definitely be cool to do sometime. I almost think it may be better to hit some of it like as we do things like this, just because like it's almost, I feel like sometimes it's like too abstract, like just the like ZIO schema, and like it's kind of easier to engage with it when you're dealing with it in a particular domain. But I will try to spend some time on ZIO schema here, which admittedly will make us take longer on actually building our actors thing, but I think is probably a good thing. But see, the idea is that this schema describes the structure of data, so that if we have like a case class that has like a int in a string field, it knows that it's a case class and it has two fields, and the first one's an int and that the second one is a string. And it can use that information in a bunch of different ways, but I think particularly for us, importantly, to generate encoders and decoders. And so the idea is that now that we have a schema here, let's go back to this. So now this get is not just giving us an actor, but is giving us an actor and a schema. And so let's think about what we can do with the schema. So one of the things we can do is we can derive a binary codec from it. So basically, we got these different terminology. We've got this schema, which describes structures of data. And then we've got codecs, which are encoders and decoders together. And then we've got a particular type of those of binary codecs that the thing they encode to is just a chunk of bytes. So here, if I can, so it can actually support a whole bunch of different ones. So one of the choices, like just with ZIO schema, we can generate a protobuf decoder. We can generate a codec. We can generate like a JSON-based one. So we can use a whole bunch of different ones. I think maybe we'll use the JSON one right now, but we have a whole bunch we can use. So I'm gonna, if it's codec.all that I need to import here. And then I believe what I can do is I can do binary codec is equal to, let's see, I think it's JSON codec dot, let's see, schema-based binary-based schema. I'm trying to remember the exact. I have to hop over to ZIO schema here to remember the exact one of these, unless someone, let's see, I'm gonna just hop over to ZIO schema for a sec and look at this. Schema-based binary codec. Schema. So now, again, if I put the type annotation on this, and we just look at what this is for a sec. So this is now a binary codec of this kind of unknown type, because this just came from this random map. So we don't actually know what type it decodes into. We just know that it decodes into some type. Hey, Daniel, awesome. You summoned him. Very cool. So now that we've got the binary codec here, which is not an int, but is just a binary codec, so then I can use that binary codec to try to decode this request into a typed value. So I could do binary codec dot decode actor request dot value, and that's going to give me an either, because it could be that I failed to decode it for some reason. Or it could successfully decode it into a message. So here, again, I can probably just die here with some, sure, I can just maybe die with my original error here. See, I think the error is a string. No, the error is a decoder. Okay, so I'll just turn it into a string. That's fine. Okay, if we have a message, then I'm in a position to call the actor. And I think I probably will need to do some typecasting here. I don't think, so let's just not do this for a second. Let's see the error we get. And we see that we decoded into some kind of unknown type, but we don't know if that type matches the actor's type here. So what I kind of want to do is I want to do something like as instance of actor any. But I don't think this is going to quite work because it doesn't have the right kind, because the actor expects the message parameterized on a type. I can actually just get around this by doing something like type any message is equal to any. And then I think I can just say this is an actor as instance of actor, any message. And I think maybe I will just create a package object here. And maybe I'll pull that in there just so I don't have that randomly sitting in my code. Okay. Does this make sense to everyone here, what we're doing on the server side? The server now has, for each actor ID, it has the actual actor and it has a schema for this actor. And so when it gets in an encoded request, it uses that schema to decode the request, and then it feeds that decoded request to the actual actor here and calls it. Okay, so far we got the server side version of this. Now there was one place that I put a question mark here that is important, that like the schemas actually have to come from somewhere. So right now they're coming from this question, which obviously is not going to work for us in the bigger picture here. So what I'm going to do, and usually the way you want to actually access these schemas is you want to require them as implicit parameters, or in Scala 3 as givens. So here, I think I'll go to this make message. And so I could say implicit schema. This is going to be a schema of a message of a response. And then in here, I can put the schema. Now, this is probably going to create some other issues that we'll have to solve in a second, because now we actually need to have schemas for this thing. And so we'll see that in a second in our example, but let's just do this first. So the first thing here we got to change is, since I added this here, I'm implementing a trait. I need to actually update my definition of the trait. And so now I'm getting an error here in my example, because in my example, I'm trying to call this actor system.make, and it's, I mean, in a somewhat long-winded way, is basically saying it could not find a schema for temperature messages of any. So let's help it out here. So in my schema companion object, I could just do implicit val schema temperature message any is equal to derive schema.gen temperature message any. And well, I think it will work once I actually import the things that I'm calling. And there we go. So, well, I don't think it should fail here. This is, it's a sealed trait that has two cases. One of them is just a case object. One of them is a case class that has a single value that's a double. So I don't think there should be any issue in deriving this. I think for other reasons we may get rid of the type parameter at some point, but this seems to at least work. We can try running our example. I mean, admittedly, we're not doing something with the schema right now because we're just doing the local case, but seems to work. I don't know, we can do another. Let's do another little example for ourselves. Object example 2. So I'll just do scala.out for this one. And let's message Yeah, so Nabil, exactly. It's just a phantom type that's representing what this is going to return. You can see that this response type doesn't appear anywhere here, right? Like this one's parameterized on double, but there's no double here. This is parameterized in units. There's no unit there. Okay, so maybe I'll skip on the example, but yeah, that's exactly why. Okay, so this is now compiling. So now we've done the server-side version of the send case. Let's do the same thing now with the ask case, because I think that's going to reveal a little bit of an interesting issue that we're going to have to confront here as we work on this. So just because these are relatively similar, I'll start by copying this. And so a lot of this is correct, right? We want to look inside the ref. We want to look inside the map. It's not there. We want to blow up. Oh, I should use string interpolation here. So if there is an actor here, then I want to use this codec to decode this thing. And I want to call the actor, but now I want to do ask instead. But now I'm approaching a little bit of a problem here. And I think I don't have a lot of type safety in here because I'm casting a lot of these things. So this isn't fully getting realized here. But my problem is basically that when I call ask, I've now gotten back a typed response from the actor that I need to give back to my client. But what I'm supposed to return here is this actor response. So what I conceptually need to do is I probably need something like map, right? And this is going to be like the response. And then I'd like to do something like encode the response. And then put the response into an actor response here. Now, can someone tell me what's wrong with this? Wrong. Yeah, Naveed's exactly right. It's the wrong schema. So we were actually, I think, a little bit too simplistic in saying we only need one schema, because I think we basically need two schemas. We need a schema for the requests, and we need a schema for the responses. So let's start working on that. And I think essentially we'll just add another schema here, though I think this will then push us to look at also making some changes maybe in some of our type signatures. But let's try to just push this through first, and then we'll kind of work from there. Yeah, so while doing that, I think that's what I was saying before, that yes, this map is definitely, I mean, I think maybe this needs a new type, and then the map also could be a new type. I think I'm going to right now just push on kind of making the change, but yeah, I think that will be coming. And I think that this is turning into like an extended set of sessions, but hopefully you folks are enjoying it. And yeah, I mean, it's kind of fun to work on this stuff. Okay, so let's go to all the places where, so no, it doesn't assume that all the response, it assumes that each actor's responses will have one common schema for them, which I think we will get to in a little while of like what that's going to mean from the user side. But I think that's probably a constraint that we're going to need for this to work. Though Naveed says, makes sense for ask to also give you back a schema, but only from the actor API, not the actor ref. So let's kind of play with your idea. So you want to say that this essentially returns like a response and a schema for it. Is that what you're saying, Naveed? Yeah, so at least to me, this feels like a little bit of a like implementation leak here, right? If kind of you need to give a schema back for each of these. I think the other issue that we have here is when we actually make these, notice that there's only one kind of response type because we unify all of these. So I think one of the things you see in our existing signatures is if you like go to our example, like notice how, okay, these seem like they have more specific types, but when we actually go and do things, we have temperature message of any because these things just get unified to being any. So I think another way to do this is to say that I think basically what we're going to have to say is that just like actors have to have a message type that they accept in, they have to have a basically output type that they export out. And I think we'll see that in a second. And it does have a little bit of trade-offs, but I think it's going to make sense here. Let's kind of push through making these changes, then we can look at kind of where we end up here. So basically now we could say something like we have a request schema and a response schema. And here we'll also have a request schema, and here we won't need the response schema. And then in the actor system, we'll have these additional ones. And right now, I'll just let this be a request schema. Schema. So then this, to be a little bit more clear on what this is, then this is really the request binary codec. It's coming from the request schema. And so then here, this is really going to be the, so here we need a new one, right? We need something like val response binary codec equals JSON codec from the response schema. And then we could use the response binary codec to encode this. We're giving Daniel some fun times. Okay, and then here I'll again just deal with the fact that I have 3 cases here. Okay, so now everything is compiling again. My issue right now is I have one question mark I need to deal with, which is this one right here, which is the response schema has to come from somewhere. But let me look at, I got a question. So Nabil says, fast return schema, be dynamic typed. Okay, well, we can have some debates, but let's kind of explore this. So what we're then saying is that in addition to this request schema, I need a response schema, which is a schema of response. And I've got to update this as well. So now everything is happy here, but let's go back to our example, which is, I always like having like one example like this that's part of the compilation, because you kind of see like, what are the actual implications of the like things you're doing? And so here, you can see now we've got a little bit of a problem, because it says no given instance of schema any was found for the response schema. And notice that any is kind of what we need to look for, because the response is either a unit or a double, which as far as this make is concerned, the unification of unit and double is any. And going back to Nabil's point earlier, here we could get away with there being this any in there because it was just a phantom type. But if I try to do implicit val response schema, schema any is equal to drive schema.gen, this is going to be a no-go. And I think it's even more specific. Deriving schema for scala.any is not supported, which is very understandable, right? Of like, if it could literally be any value of the world that I make up, how are we going to understand the structure of it? We don't know the structure of it. So what I think this pushes us to do, and I mean, I think there are definitely different ways we could approach this, but I'll kind of put out one, is just like we have this temperature message, we're basically going to have, maybe I'll call it sealed trait temperature response. And so object temperature response is also going to have some cases, and maybe let's just be really simple here. So we'll say case object temperature set. It's going to be a temperature response. And maybe I'll make this set temperature just to be like consistent. And then this could be case class get temperature that will have a double inside it. It's going to extend temperature response. And now this is really a very simple type where I can definitely derive a schema for it. And now the upshot of that is just that this now needs to get parameterized on this type instead. So here we can say this extends temperature message, temperature response dot set temperature, excuse me. And this will need just dot type because it's case object, and then this will be temperature response dot get temperature. And now the schema that we're deriving is actually one for a temperature response. This we don't need here. And now I think we'll be in a little better shape. Let's see what we got going on. So this is just any, which works. And now here, I think we're running into some type inference issues that I think we may be able to improve. But first, let's just get this working. So if we go to make here, yeah, VS Code does not help me out here. But this is the actor system.make. So if we go to the actor system, it's environment, state, message, response. So we can make this any, the state is double, the request is a temperature message, and the response is a temperature response. Again, I'd like to make that nicer, but temperature message. And let's see what. Oh, and then I just need to update these. So basically, this one is just going to be a temperature response, and then this is going to be temperature response get temperature with the state. And then let's see what I got going on here. And this I think just needs the type, I believe. Don't want that. No given instance of a schema, the temperature message, temperature response. Um, Not understanding right now why we're not able to derive these schemas. Let's see, are these, no, these both extend temperature response. No. Make sure I have, oh, I know. Oh, this is expecting a parameterized type. Maybe do need to clean that. There we go. Now everything is compiling. Okay. So now we're saying when we make an actor, let's go to like our actor system.make. So this is now parameterized on this message response and response. And we've got a schema for both of them. I think a little bit of the question now here is this type parameter pulling its weight? And I'm inclined to think not. I'm inclined to think that basically this should just be message instead of message and response. And so your pattern is more like what you have here, where you say like, look, this actor, right, it's got a pretty clear protocol of it takes in these types of messages and it gives these types of responses. And then we have a schema for each of them. And that also just simplifies things a little bit because I think we can see that like having this type parameter here has some cost to it. So I think that could be a good simplification to do. But now, I think we're still not actually using any of our, oops, let's see what's not implemented yet. Let's see, an implementation is missing. Let's find that question. Oh yeah, so those are the remote cases. Let's see. Shouldn't be hitting those though. Let's make sure I've saved everything here. I at least have my example working before. So where is this? Oh, okay, exactly where we're for. So now that I've got my response schema here, I can just put the response schema into the map here. Now my simple example works. And now when I go back to my actor system service, now I think I've got a sound approach to doing this, right? Where I get the request in, I use the request codec to decode it. Assuming I've decoded it successfully, I send it to the actor, it gives me back a typed response. I use the response codec to encode it back to binary, and then I send that binary back to the client. So I think now we kind of balance and forth, back and forth between doing a bunch of things, but I think now I've got this actor system service implemented, which with everything else I wired up, I've got my routes, I've got my app, I've got in the actor system here. I'm starting my server that is taking this in. So we actually, I think, did a lot here of we basically, I think, got the server implementation done. So I think the next step, which probably we'll do not next week, but because next week's Thanksgiving, and actually the week after that is functional Scala, but we'll do in December is we'll go through and we'll use those endpoints to generate clients, and we'll basically call those clients here. So we'll say, hey, if we call a method on an actor ref that's local, we'll just run it right here. If not, we'll use this client to call the server that's actually owning that actor, and it will run the actor and it will give us back the response, and then we'll give that back. So I think we need to implement these two things, which are going to get us using the client generation versus the server aspect of the endpoints API in ZIO HTTP. And then we just need to actually make sure everything's working and we're calling the right hosts and we have things lining up. And then I think we can probably do some time on kind of ergonomics and features of as I think I'd like to blow away this type parameter. I think we need some concept of the ability to access some context when you're defining the actor here, particularly the self actor ref, so that we can send a message that has a reference to ourselves so someone else can send something back to us. But I think we made pretty good progress today. Does anyone have any questions before we break for the day? I see one's typing, so yeah, I'll give folks a couple minutes. No, that will just get translated back to the client. Okay. All right. Well, cool. Well, I'll push this up, and yeah, for those of you, at least in the US, have a great Thanksgiving next week, and hope to see a bunch of folks at functional Scala. But we'll continue on this. Hopefully you're enjoying this. Definitely give me feedback on if you're liking this, you want more of it, or if you're I'm so tired of actors at this point and I want to do something different. We can definitely kind of take a break at some point and come back to this or do other things. But yeah, always love your feedback. Okay, have a great weekend.